In the second part of Lesson 13, Precalculus, we graph rational functions using powers of factors in the numerator and denominator to help us graph. This is section 3.2 in the College Algebra textbook. We get started by graphing h of x equals x squared minus 2x minus 3 over x squared minus 2x minus 8. First of all, I will factor the numerator and denominator of h of x to give me x minus 3 times x plus 1 over x minus 4 times x plus 2. Then to determine the x-intercepts, I need only look at the factors in the numerator, set each factor equal to 0. I have x minus 3 equals 0 and x plus 1 equals 0, from which we get x equals 3, x equals negative 1, for x-intercepts of negative 1, 0, and 3, 0. The y-intercepts come from setting x equal to 0, so I have y equals 0 squared minus 2 times 0 minus 3 over 0 squared minus 2 times 0 minus 8. And this simplifies to 3/8 for a y-intercept of 0, 3/8. The vertical asymptotes come from setting the factors in the denominator equal to 0. So x minus 4 equals 0 gives me a vertical asymptote of x equals 4. X plus 2 equals 0 gives me a vertical asymptote of x equals negative 2. The horizontal asymptotes, we look at the degree of the numerator, which is 2, and the degree of the denominator, which is 2. Since the degrees are the same, I'm going to look at leading coefficients of each. And my horizontal asymptote would then be y equals 1 over 1 or y equals 1. Now, for graphing, putting all of this information together, I start by plotting the intercepts on the graph, then adding the vertical and horizontal asymptotes. What we've been doing is we've been plotting some extra points, finding x values between vertical asymptotes and x-intercepts, which we have some points here. And then after those points are plotted on the graph, we draw nice smooth curves that pass through those points and approach asymptotes in each of the three regions here. Note that this is a perfectly fine way to graph a rational function. It's just somewhat time consuming if you have to plot a really lot of points to get your graph. So I have a shortcut method of sorts that we'll work on here. We start out the same, graphing the rational function by first plotting intercepts, then vertical and horizontal asymptotes, and then rather than plotting extra points, I will factor h of x and look at the factors and the powers of those factors. So the first thing I'm going to note here is that the y-intercept of 0, 3/8 is above the x-axis, as you can see here. With that y-intercept above the x-axis, I know that between x equals negative 1 and x equals 3, where my x-intercepts occur, I am going to have all positive values for y. In other words, my function will be graphed above the x-axis in that region. I'm going to go a bit further here and look at what is happening at x equals negative 1. So if we look at the intercept negative 1, 0, does my graph cross or touch at that point? Well, this is similar to when we were graphing polynomial functions. I look at the factor from which that x-intercept came, look at the power that that factor is raised to in the numerator. That 1 is an odd number, so that tells me that my graph is actually going to cross the x-axis at the point negative 1, 0. Okay, and as usual, it approaches the vertical asymptote as it heads on down. Then if I look at my other x-intercept of 3, 0, that intercept comes from the factor x minus 3, also raised to the odd power of 1 in the numerator of h. And so I know that my graph is also going to cross the x-axis at that point and is going to then head on down towards the vertical asymptote. Well, what's happening to the left of x equals negative 2? So let's concentrate on the asymptote x equals negative 2 for a moment. Where did I get that vertical asymptote from? It came from the factor x plus 2 in the denominator, which is raised to an odd power of 1. Well, we can get similar results with the vertical asymptotes if you note that the function itself is going to change from negative to positive or positive to negative at x equals negative 2. And so in other words, if to the right of x equals negative 2, my function is approaching negative infinity as it is, to the left of x equals negative 2, my function will be approaching positive infinity. Then if we move on to look at the asymptote of x equals 4, note that at x equals 4, to the left, my graph is approaching negative infinity. Where did x equals 4 come from? Well, it came from this factor in the denominator of x minus 4 that is raised to the odd power of 1. And the odd power of 1 tells me that my graph will be approaching a different direction to the right side of the asymptote. In fact, my graph will be approaching positive infinity as it gets closer and closer to this asymptote from the right side. So this is a bit quicker. Once you get going on this, you can graph fairly quickly using this method. To check that what we've done is accurate, though, I suggest taking some points to the left and right of x equals 4 here and verifying that the function indeed does change signs. I'll let you try that on your own. Now, moving on to graphing j of x equals x minus 5 squared times x plus 3 over x minus 4 squared times x plus 2. And note we have some even powers on our factors here, which will give us a little more information. We start by finding the x-intercepts. We set j of x, or y, equal to 0, and we find that we have x-intercepts when x minus 5 equals 0, or when x plus 3 equals 0. In other words, or solving these equations for x, when x equals 5 or x equals negative 3, giving us x-intercepts of negative 3, 0, and of 5, 0. The y-intercept comes from setting x equal to 0, so it would be y equals 0 minus 5 squared times 0 plus 3 over 0 minus 4 squared times 0 plus 2. We simplify, well, we get 25 times 3 is 75 over negative 4 squared is 16 times 2 would give us 32. We have a y-intercept of 0, 75 over 32. For asymptotes, the vertical asymptotes come from the factors x minus 4 and x plus 2 in the denominator. Setting x minus 4 equal to 0 gives a vertical asymptote of x equals 4. Setting x plus 2 equal to 0 gives a vertical asymptote of x equals negative 2. The horizontal asymptote, we look at the degree in the numerator and the degree in the denominator. Let's take a look at the leading terms in each. If in the numerator we have x squared times x raised to the first power, that would give us a leading term of x cubed. In the denominator, again, x squared times x raised to the first power, we again have a leading term of x cubed. So the degrees are the same. I look at the leading coefficients to help me determine the horizontal asymptote. It would be y equals 1 over 1 or y equals 1. All right, moving on to graphing. We plot the intercepts, negative 3, 0, 5, 0, and 0, 75 over 32. We plot the vertical asymptotes, x equals negative 2, x equals 4, and the horizontal asymptote, y equals 1. And something that's kind of nice about this graph is not only is my y-intercept clearly above the x-axis, but there are no other x-intercepts between these two vertical asymptotes. So in other words, I know that my graph cannot cross the x-axis between the two vertical asymptotes. So it's going to have to be heading upwards and approaching each of those asymptotes. Then, if we want to determine what's happening, like we're good in that middle region, let's go to the left a little bit. So heading to the left side, we can see our graph is approaching positive infinity to the right of the vertical asymptote, x equals -2. I want to know where that vertical asymptote of x equals -2 came from. Well, it came from this factor of x plus 2 that's raised to an odd power, and that tells me that to the left side of x equals -2, my graph will be headed in an opposite direction, or will be approaching negative infinity instead of positive infinity, as it is on the right side. Well, what's happening at x equals -3, at the intercept -3, 0? We're either crossing or simply touching and bouncing. -3 comes from the factor x plus 3 that is raised to the odd power of 1. So my graph is going to simply cross at that point and then approach, as it heads to the left, it's going to approach the horizontal asymptote of y equals 1. So we got that taken care of. Now noting that to the left of this vertical asymptote, x equals 4 here, to the left my graph is approaching positive infinity. Let's look at where x equals 4 came from in our function. It came from the denominator. It came from the factor x minus 4 squared. So here we have an even power. With an even power, to the right side of that vertical asymptote, my graph is going to be headed in the same direction as it is to the left. It doesn't change direction. And the only thing I have left to finish off this graph is look at what's going on at the intercept 5, 0. Well, the 5 here comes from the factor in the numerator of x minus 5 squared. Since 2 is an even power, my graph is simply going to bounce off the x-axis at that point, and then it's going to bounce up as it moves to the right, approaching the horizontal asymptote of y equals 1, and we're done. Try on your own number 2. Find the intercepts and asymptotes and then graph the rational function. Include intercepts and asymptotes on your graph. Use dashed lines to show asymptotes. We have r of x equals x minus 1 times x plus 2 squared over x minus 3 times x plus 4 squared.